Hey guys, what's going on? Today I'm going to show you how to build an app using LangChain to interact with PDF documents for free without using OpenAI's API. So without any further ado, let's get started. Alright, so first, I'm going to give a high-level overview of how our project is going to work. So we have a PDF file, and we're going to extract data from it using a library in Python. Then, we're going to split our data into separate chunks. Now, the reason why you split it into separate chunks is because in order to answer a user's query, we do not need to look at the entire document. Rather, we need to look at only certain parts of it. And if you've ever worked with a large language model before, a large language model like ChatGPT, you know that you cannot. There's a limit to how much text you can pass to it as input. So we cannot feed the entire document to a large language model. That's why we're working with separate chunks of the document. And then for each chunk, we're going to be computing its embedding. Embedding is simply a vector representation of the text. Now, all of these embeddings are going to be stored in a vector database, which is our knowledge base. And then when the user makes a query, we need to compute an embedding for a query again, which is a vector representation of the text. Then we're going to perform a semantic search on a vector database to extract relevant information from our knowledge base in order to answer the user's query. Now, this will be passed as input to a large language model. A large language model, again, is simply a deep learning model like ChatGPT, which is used to work with text data. Now, this will generate a response, which will then be passed back to the user. So for this project, we're going to be working with PyCharm because it's very easy to use and it's beginner friendly. So before we start working on our project, we need to make sure that we've installed all of these modules because we're going to be needing them in our project. What you can do is you can put all of these in a requirements.txt file, then run this command on your terminal, which is pip install -r requirements.txt, which will simply install all of these modules. Alright, so once you've installed all the required modules, just create a new Python file and then import all the required dependencies, which are these. And then we need an access token in order to use services from Hugging Face. So I've set it up as an environment variable here. And then in order to get the access token, you need to head over to the Hugging Face website. Head over to settings. Go to access tokens. Generate a new token. And then copy. And then paste it here. Alright, so now we can begin to work on the user interface for our app. So for that, we're going to be using Gradio, which is an open source library which lets us build UI components for our machine learning app. So I'm just going to go ahead and type with gr.blocks as demo. So this is sort of like a container inside which we're going to store all of our components. And we're going to be working on this part by part. So let's do the PDF file uploader first, which will be gr.file. We need to give a label, which will just be a file upload. And we also need to specify the file type, which will be a .pdf. And then we also need to do a demo.launch to launch our app. Then we can just go ahead and run our program to see what it looks like. Alright, so our app is running on this local URL, and just click on it. Alright, but now it doesn't really do anything if we upload our file. And as I mentioned earlier, we need to be able to take our PDF document, we need to split it into separate chunks and then compute its embedding and then store it into vector database. Now let's write a function in order to do that. So I'm going to write write a function called process PDF, and we're going to pass a PDF file object as an argument. And then the first thing we need to do is we need to use our PDF loader to load the PDF files. So need a loader, PyMuPDF loader, and we need to pass in the name of the file. So this file object right here, it has an attribute of name, which is the name of the PDF file, and then we need to go ahead and load in the documents from the file using loader.load. Alright, so once we've done that, now we can specify our embeddings. We're going to be using the Hugging Face embeddings for this, and then we need a text splitter in order to split our text into separate chunks. So I'm going to type a character text splitter, and we need to specify the chunk size, which is basically how many characters will each chunk have. So I'm going to use 1,000 characters for each chunk. And then we also need to specify the chunk overlap, which is how many characters will overlap between the chunks. So I'm going to give it a value of 200. So that means 200 characters will be overlapping between adjacent chunks. And then we need to go ahead and use this text splitter to split our documents. So our text is going to be text splitter split documents, and we're going to split our documents into separate chunks. All right. Then we need to actually store all of the we need to store all of these all of the vector representations of the text into a vector database. In order to do that, we'll just type in chroma dot from documents, and we need to pass in the text, which is our chunks, and we need to specify the embeddings. So this is going to do that step for us. Alright, so then we need an LLM. So we're going to be using a large language model from Hugging Face, which will be open source. And then we need to specify the repo ID, which is the name of the model. So we're going to be using OpenAssistant. However, if you want, you can use others like Google Plan or bigscience clones. I'm going to be leaving a link to them in the description, so you can just paste it here. And then we need a chain. A chain can be thought of as what connects our large language model to the vector database. So we have retrieval QA from chain type, and then we need to specify the LLM as our first argument, which is this variable here, and then we have the chain type, which is stuff, and then we have our retriever. We're going to be using our database as our retriever to retrieve all the relevant information in order to answer the user's query. So once all of this is done, we can finally return a string which says document has been loaded successfully. Then I'm going to set up a row, so with gr.row, and this row is going to have two things. The first one is going to be a button to load the PDF, which is just going to be gr.button. It's going to have a label which is going to say load a PDF, and then we're going to have a text box which shows the status of the file. So we're going to do gr.textbox. It's going to have a label of status, and then we have a placeholder which will initially be an empty string, and then we need to set interactive equals to false, meaning we can't explicitly change its value. Alright, then we need to decide what's going to happen once the user clicks on the button. So we need an event listener for that. So load pdf.click. So what happens once the user clicks on it? We're going to have to call this function right here, process PDF. So that is the first argument, the name of the function, process PDF, just the name without the parentheses. And then we need to pass in the input. So the input to this function is a PDF file object, which is what the user uploads right here. So a PDF file, is the input, and then we have our output of the function, which is a string, which implies whether the document has been successfully uploaded or not. So we can just place that in our status to show that the document has been uploaded. So I'm going to do this type status. So once the user clicks on the button, it's going to call this function, pass the file as input, split it into chunks, and then load it into a vector database. And it's going to pass back a string, which will then be placed inside of this text box. Alright, so I'm going to set up another row with gr.row to set up another row, and then this is going to have two things again. First, which will be an input. This is going to be a text box. It's going to have a label which will say type in your query. Then we're going to have the output, which will also be a text box, and it's going to have a label which will say output. And then we need a button so the user can submit their query. So gr.button, and then it's going to have a label which will say submit. Now we don't actually need to write label is equals to specify the label for the button, so we can just remove that from here. And another mistake that we made was this right here. So we have a small spelling mistake which is going to cause an error. So I'm just going to change it here. So it's supposed to be IE. And then we need to add an event listener. So we need to decide what is going to happen once the user clicks on this button, submit. So we need to define a function which is going to use this chain right here to generate a response based on the user's query. So let me just show you. I'm going to define a function here which will be called answer query, and it's going to take a query as input, and it's going to return chain.run of query. Now because we're using chain here, we need to make it global, so it's accessible within this function. So I'm going to type in global chain. Now what's happening here is that this function is going to take the user's query as input. It's going to compute its embedding, perform a semantic search on the vector database to retrieve the relevant information, pass it as input to the model, to the language model, along with the user's query, and then it's going to generate a response which will be sent back as a string as a result of this line. So that will be our output. So now we need to pass in the arguments. So the first argument is going to be the function, which is answer query, just the name of the function without the parentheses. Then we need to specify the input, which will be this text box right here, whatever the user types in this text box. And then we're going to have the output. The output is what is going to be returned from this function. Then it's going to be placed in this text box right here. So that is the output which this is referring to. Alright, so now we're basically done. Another thing we can do is we can add a theme to make the design look a bit better. So we can do theme is equals to a gr.themes.monochrome. So this is just one of the themes. You can try others as well. I will leave a link to those in the description. So now we can just run our program to see if it works as we expect it to. So as you can see, it has the monochrome theme, and you can upload a file, you can load a PDF, type in your query, and then submit. Now let's test to see if it actually works. I'm going to just upload a file, a PDF file, and then I'm going to load the PDF. Okay, so the document has been loaded successfully. Then we can type in our query. So what is the title of this document. We can just press submit. Okay, so it says introduction to set 3. Let's see if that is correct. So I have this PDF file here. So it is indeed about sets. So the answer is correct. Now let's ask something else, such as what is the summary of this document, and then press submit. So it says the document provides a brief overview of 3 kinds of set, and indeed it does. Alright, that's it for this video. However, there's 2 drawbacks for this project. The first one is that because we're using an open source model, it's obviously not as good as OpenAI's model. So the response which we get back sometimes is not of very good quality, and it's also not very accurate. And also, if we try to upload a file which is very large in size, you will run into an error because there's a limit to how much tokens it can handle as input.